Hello. Now, in our discussion of today, we would like to look at electronic components. Just right with you, right before you here, is a pair of earphones. Now, these are some of the electronic gadgets that you basically use every day. You have it with you. I also have one with me right here, though it's a little bit different from what I'm showing you. But all these ones are electronic gadgets. We call them electronics components or electronic gadgets that are, that are in daily use. We use them, we charge them, they break, we lose them, then we buy new ones, So these are things that we use basically every day. And it's now important that we get to understand how do they really operate, how do they work. So this is another one. Look at it. Yes, you guys look at this. So these ones are, other forms of electronic gadgets. You would like to call them iPhone 11 or something like that. These ones are electronic gadgets that we use basically every day. These electronic gadgets makes our lives a lot easier in communication, entertainment, relieving stress and stuffs like that. We can even do gymnastic using these stuffs here. There are some mobile apps you can get right inside, can guide you through some physical exercise to do and get better. You can carry out a lot of things, you can even check the temperature of the room. So we do use these electronic gadgets a lot and on a daily basis, basically. And it's therefore very important that we get to understand how they really operate. It's very important that we understand how they really operate. Are we going into the technical details of its operation? Not necessarily the technical detail, but because we use them, at least we need to understand some basics about how they work, how they operate. And so, we'll be going through that in a minute. So yes, that's an iPhone, or some iPhones there. You would like to grab one, then just find yourself. And yes, this is another one. Check this out, guys. See this. This is looking wonderful. Look at it. See this? Now, this is another form of electronic gadgets that we also basically use every day. You use them for entertainment, you use them to communicate, you use them, basically to do everything, most of the time. You really need to refer to this. You want to write your exam, you want to write something, you want to talk about something, you want to keep something. We use these gadgets. And so in this topic, in this chapter, we are basically going to be looking at electronic components, okay? We are going to be talking about how these things really operate, how they get connected, what do they base on to operate. In very simple terms, these things to operate needs electricity, they need power, they need battery. You see that? All this that we have seen, you can talk of this MacBook, this laptop, or you can talk of the iPhone, you can talk of, these earphones. They all operate when we have a power source, when they are charged. That meant when they have a battery. You see that? And then when they are having a battery and the battery is charged, that means they can operate normally. So yes, we will be looking at some basic components. We will not really go into the technical details of, how these things are connected, because the technical details will be too much for us. Look at these guys, you see? So this is basically like, a section of the internal components of a telephone. Now, are we really going into that? No, we are not going into this. We're not going into these technical details, like how, which line is connected to what this is supposed to representing. No, we'll not go into that detail, but at least you need to see so that you understand that the phone you have with you has got this complex internal component. And that is also one reason electronics is a very important chapter in what you need to study. And yes, there is also this Okay, this is now basically a phone which has been opened. You know, we are not really going into the detail, but I just wanted to show you something. You may not have really to break your phone or open your phone to see this, you know. Yes, this is also earphones, you know, or headphones. So these are some of the components, you know, the connections inside. And now here is our MacBook. Look at it. You see how they have broken it down into pieces. So yes, we have these components. And now that we have seen a little bit of the picture, well, what are we heading to? Well, basically, as I indicated, what we will be looking at will be simple circuit diagrams, how we are going to be connecting these cells. We will be calling them cells, okay? The batteries, the things that provide the electrical power which is needed for these electrical gadgets. We will be calling them the cells or batteries sometimes. So we'll be looking at some circuit diagrams, and we'll also be looking at how we connect, you know, some minor connections here and there, you know, connecting a cell like a battery. Like, for example, the remote you have with you right at home. This remote that you have with you right at home, you know, has got some batteries inside, has got some cells inside. So please make an effort. You can open that, you know, that end out. You can open that part of the where they keep the battery, where they keep the cell. You can open that. You know, normally you do that when the battery is off. You know, like for example, when the power is off, you open that and you put new batteries. You could check that out. What I would like you to find out is how are the batteries connected? How are they connected? Are they connected like one end to the other? I mean, like when you open your battery, what do you find when you open not the battery, but when you open the what? The remote, what do you find? Do you find this type of arrangement? Do you find the batteries connected like this? Is this what you find? Now I need you to respond to that. I need you to go open that remote of yours, the one you have at home, the TV remote or the remote for, you know, some other gadget that you have, but majorly the TV remote. Just open that part where there is a battery and tell me, is this how they are connected? If you find that they are connected like this, then you say they are connected in series, because this is how we call a type of arrangement. So when you see that it's connected in such a way that, well, the head, this we call the head, if the head of one battery is connected to the tail of another battery, then we say they're connected in series. For example, look at this. So here we have the head of one battery. How is it connected? Well, it's connected to the tail of another one. And even right here, what do we have? Well, do have here the head of one battery connected to what? Connected to the tail of another battery. Even this other one, when you look through, you notice that the head of one battery is connected to what? Is connected to the tail of the other battery. So yes, when the connection is a head to tail, then we say that is a series connection, okay? And then how do we find the voltage? How do you find the electrical energy? How do you find the total amount of the electrical energy which is stored there? Well, we just add this other one. For example, you can see here they've written 1.5, just like here they've written what? 1.5, and here they've written 1.5, and also here we have written 1.5. So if we want to find out the total voltage, okay, the voltage is the electrical energy which is carried inside these batteries here. So if you want to find them, then you'll be like, well, 1,5, okay, that you have to add. That is for the first one here, okay. This is for this first one, it's 1,5. Then what do? We are going to add. What do we add that to? Well, we add to the second one, which is also 1,5, okay. Then what else do? We add. What do we add to? We add to the voltage of the second one, rather the third one. And what is it? It's also 1,5. And then we continue with the adding, okay? We keep adding that way up to what? Up to 1,5, which is the last one. Then that way, okay, we can add them all. Notice that when we add this 4, that is 1,5, 1,5, 1,5, 1,5. When we add all of them, what are we going to get? You could guess that, okay? You could guess this, and if you guess 6, then that will be right. the total voltage is what? Is 6.5 volts. So yes, this is about batteries that are connected in series. So for batteries that are connected in series, what we do is we add the individual value of each battery from the first battery to the last battery. And when we do that, what we find is going to be the what? The total voltage, or the total amount of electrical energy stored inside these batteries. Now, what if we are not going to be drawing this diagram? How else can we represent these batteries? Well, this is how we represent what? This is how we represent with the diagram, okay? This is called the circuit symbol. Now, when it's time for us to draw the circuit diagram, when we are done with these things of using the actual battery, and now we are using the circuit diagram, what we do is we use symbol with this short one representing the what? The negative terminal, which is right, this one here. Then this other long one represents the positive terminal, which is what? Which is this front side here. So yes, we do have the positive terminal and the negative terminal. And here we have 1, 2, 3, 4. And here you can see the first one is here, 1, okay. Then 2, well, then 3, then finally what? Then finally 4. So yes, in total we have 4 batteries that are connected in series. Another way of connecting these batteries is illustrated right here. So here in this case, the batteries are not touching one another, but they are connected using what? Using a conductor. And now because they are connected using a conductor, the conductor which is coming from the head of one is connected to the tail of the other. Then again, another conductor takes from the head of one battery and taken to the tail of the other. And the conductor which is connected across on the head of one is connected to the tail of the other, and on the head of one to the tail of the other. For as long as the connection is from head to tail, we say it is a series connection of the batteries. And to find the total battery which is inside the total voltage, we keep adding the voltage of the individual individual battery, which is here 1.5 volts, then also 1.5 volts, also 1.5 volts, and finally 1.5 volts. So we have 4 of that. And again in the schematic what? Schematic equivalent, or very much the what? Or very much the circuit symbol. That's what we have. Now these 4 batteries, each having 1.5 voltage, altogether will add up to give us what? 6 volts. Yes, that is how we deal with it. Sometimes you may be required to find the what? For example, look at it here. Determine the total voltage, which is the electrical potential. Another way of calling the what? The total voltage. We are supposed to determine the total voltage or the electrical potential for each of the following circuits below. So we have this. Notice this is one, this is another. In the same way, it's also connected head to tail, head to tail, head to tail. And so how do we find the what? How do we find the effective or the total voltage? Well, we say the total voltage for the first one. Let's say for part A, the total voltage is going to be 3 what? 3 volts. All right, then we add to what? Well, let's just put this 3, we add to 4, then we add to 6. What do we get for this? Well, this must give us 13. Yes, that is what we get. That gives us 13 as the what? As the total voltage, and this is called 13 volts. And like for the second one, well, for this second one here, to find the total voltage or to find the electric potential, what we do, we add 6, okay? We add this 6 to what? To the other 6, this first 6 and the second 6. That will in total give us what? 12 volts. And yes, that is how you determine the total voltage or the electric potential for the what? For any given circuit, if it is connected in series. And inside cell holders or battery holders, you know, for example, some of these electrical components, they have battery holders. The things, the other gadget where you place battery inside. Just like that one for the remote, there is what? There is a small section right behind there where you find the remote, rather where you find the battery and where it is supposed to be placed. So that's called the battery holder. Now, should you notice that there is a connection between these two appliances? For example, you see this is one end where the what? The positive bit or that top of the battery enters, and here is the what? Here is the other one where the what? The rear end or the negative terminal or the other tail of the battery is placed. You see there is this connection. What this connection indicates is that we are dealing with a series connection. But if you notice that this is not there, that is a very different type of connection, possibly what we call what? Parallel connection. Yes, we are still talking about these electrical gadgets and how they are used. We saw a few, the earphones, the iPhones, the MacBook, you know, those stuffs there. They all rely on a battery, and once the battery is charged, it can operate. Once the battery is not charged, it can't. So we want to see how can we arrange this battery so that we can power our electrical gadgets, so that we can give electrical power to the electrical gadgets. There are two ways of making this arrangement. The first way is to connect the head of one to the tail of the other, giving us that type of arrangement which we call the series connection of batteries. This other second type is called the parallel connection of batteries. See the difference really well. The difference here is that you notice that the head is connected to the head, and another head is connected to the head, and another head is connected to the head. Then when it comes to the tail, then the tail is connected to the tail of another. This tail is connected to the tail of another. Then again, this tail is connected to the tail of the other. You see that? So all that gives us a value of what? 1,5 volts. What this means is that when you are dealing with parallel arrangement of batteries, then the batteries that are connected in parallel will have the same voltage. They will have the same voltage, will have the same potential difference or voltage. So that is what we mean. So take care and please note this well. For as long as it is parallel connection, the voltage is the same across all the batteries. And how do we then connect that? Well, to connect that, we use this type of arrangement here. You see? So there isn't anything like connecting a head to a tail, no. A tail to a head, no. It's connected head to head to head to head, then tail to tail to tail to tail. Check this out. Tail to tail to tail to tail. Then again, from here, head to head to head to. So the conductor which is connecting, which is placed at the head of one battery, the conductor which is placed at the head of one battery moves on to the head of the second battery, and from there another conductor is placed on the head of the second battery to go to the head of the third battery, just like that until we reach the what? The last battery. And as I indicated, for this type of arrangement, the batteries will have the same voltage. And that is how we determine the voltage of batteries that are arranged in parallel. Okay, so is there a question on that? And if there is no question of that or on that, that's where we would like to stop for now. I will be getting for you an activity to do, and I will be posting that right away. So please stay posted so that you don't miss any other remaining bit which is supposed to come immediately after this. We will continue with this next time for our next lesson.